come at the right time.
All right, so all three of these review yesterday's properties of logarithms. We're gonna have one more today, which is actually easier than the others.
Please tell me you're here after school today. Okay. This is just, I'm going nowhere with this. I don't get it at all. No, it's not.
You got a chance to talk to me about this. Alright, you guys, so number one, we're given this math fact. Think about this like a math fact. What this says is 3 to the 1.465 power is approximately 5. Okay, 3 squared is 9, so yeah, that's just it's between 1 and 2. I buy that. Okay, so this is what we know. We know 3 to the first is 3, 3 squared is 9, and now we know 3 to this bit is 5. But we're asked to find 3 to what power is 25? So how are we going to do it just given that one fact? Well, your goal is kind of like a little puzzle, is you have to rewrite the argument using whatever information you've been provided. So this time, I'm going to rewrite 25 using just 5, base 5. So how can we write 25 differently? 5 and something. But you could do 5 times 5. You can turn 25 into 5 times 5. Or you can turn 25 into 5 squared. So I'm going to rewrite 25 as 5 squared. And that really just comes with practice. We did 1 yesterday. You're going to do 2 more today. You're going to start seeing the argument as a base and an exponent instead of a large number. All right. The power property says we can take this 2, move it to the front, and do 2 times log base 3 of 5. Which, when you say it out loud, it sounds ridiculous. Like, oh, you can just take an exponent and move it to the front? Like, oh, like, since when is that okay? But really, a logarithm is an exponent. So this is the exponent, right? And we're talking about this thing squared. So if we double it, all we're doing here is saying let's double that exponent to get to 25. Kind of does make sense when you say it that way. All right, so after this, we can now replace with the decimal. You rewrite all the way until you can replace it. So this is 2 times 1.465. And that's 2.93. Yeah, 2.93. All right, do I buy into this? You should ask yourself, do you believe in the answer? So this is 3 to 2.93 is approximately 25. How many of y'all think that could be true? Do you know what 3 squared is? 9. What's 3 to the third? What if we round this up to a solid 3? 3 to the third is 27. So we go just under 3 and we're at 25. So I definitely buy into that. As you go through these, you should stop and question, do you even understand what you're writing? This 2.93 represents an exponent. That's 3 to some power. Questions on number 1. You're doing this again today. All of these you're doing again today. So write the steps out clearly in a way that could be helpful to you. Your exact same steps in your work today. All right, next we'll expand. Let's get this out of here.
Oh, what's going on?
I don't know.
Oh.
Weird. I don't know why. electrical. Alright, expand. So,
Oh, that's funny. What's your nose running?
there's an order of operations to all of this that only comes with practice. So, first I'm going to start with that quotient property. This is natural log, which means we're looking at log base E. This is the most natural of the logs, the ones we see in nature. We see them all in nature. Alright, so I'm going to put a minus sign in and flip that fraction, make it subtraction. Any questions?
Oh,
I know, it's
Get it.
crazy how you can just take a subtraction problem and write it as or a fraction and write it as a subtraction.
Okay, I don't know math, but like, does it, if like the L N, can you just write it as like a capital L, just to see it more clearly, or does that like change something? Or like,
As far as I knew, no, right now, capital L doesn't have like an alternate meaning,
okay.
so it wouldn't like mess it up.
I'm gonna say.
The only thing capital L might stand for is a line in geometry. Typically, capital letters are for points, shapes, rays, lines. Geometry, you write capital letters all the time. In algebra, we do lowercase. I don't think it matters at all. Alright, next. This is 3 times x to the 5th. So I'm going to take a moment and realize that there is multiplication happening there. And I can expand using the product property. I'm going to take that apart with a plus sign. So now I have natural log 3 plus natural log x to the 5th minus natural log y. We did the fraction bars, then we did pretty much after the fraction you go left to right. The last property I'm going to do here is the power property. And I'm going to take that exponent and I'm going to write it out there in front. And this will be my final answer. Natural log 3 plus 5 natural log x's minus the natural log of y is the expanded form of that fraction.
This is just something else. Who thought of this?
Yeah, who did think of this?
Somebody had some extra time on their hands.
People didn't have calculators.
But what would you use this for, like realistically?
Probably nothing.
No, there's lots of things with logarithms. Anything where the growth or decay is exponential, and you're trying to solve for it, and you solve for exponents, you use logarithms. So they're actually some of the most real world applications we've been logarithms and exponents.
I mean, I really understood this until we got. It's always when we get to something 0.5 is when I stop understanding.
It's true. And then those last 2 sections are always
It's really confusing. Who was like,
the next one I think will be okay. Alright.
Oh,
When it comes to condensing, we're going to follow those same steps, but opposite. So the order of operations for condense is just the opposite of the order of operations for expand. So if you want to make a note, I would start with any power property. So you search through, you're looking for numbers in front of that word log or in front of ln, make it an exponent. So that's the first thing you do is you take those numbers back to the exponent form if you're trying to shrink it back up. So this is log 6 plus log, wait a minute. I almost messed up. Y'all, what's the base of these right here? Yeah, those are invisible 10s in there. You can write them in if you want. Invisible 10s, invisible 10s. Those are the common logs. Those are base 10. Okay, let me try this one more time. So it's log bigger than 6, log 3 to the 4th, log 3. Alright, next, after you do your power properties, you condense from left to right. You read your math sentence left to right. So the next thing I would address is this plus sign. That's the product property. We'll condense that through multiplication. Log 6 times 3 to the 4th minus log 3. I think I'm just going to go ahead and hit a calculator and do 6 times 3 to the 4th. Yeah. When you condense, that word in itself means you're dropping logs. You're bringing it together so you're writing log less. So when I switch from plus to multiply, I don't have to write the log again. That's the whole thing. So okay, good question. Alright, so this is actually log 6 times 81 is 486 minus log 3. And now last is the quotient property. 486 over 3. 486. Because I did 6 times 3 to the 4th power. Multiply the arguments.
Oh, and we're not done.
No, of course we are.
Done.
Now we're done.
Something's done. Okay, so that is a full review of yesterday's class, and we're practicing it again today. There's only one thing I'm going to add to it, and I think you're going to like it because it's using your calculator. So I'm finally going to tell you guys how to do some logs in your calculator.
Are you on your phone?
Alright, so before I check yesterday's assignments, I'm going to give you a little bit of notes over here.
Oh goodness gracious.
On the whiteboard notes.
I love notes. Woo!
And
Louis, do you love notes?
alright, you're gonna like this because again it's calculator work. So you figure it out. Now, to be honest with you, your calculator's pretty fancy. Your calculators can do a lot of this stuff, but this is more like how to do this with a basic calculator. So there's one more formula and it's called change of base formula. It's on page 595. I have simplified this extremely. So I encourage you to read page 595 because your textbook, they tell you a lot of really good, important details. It's a great resource. So this is very simplified. If you're feeling like I really need more information about this, then you should use your textbook, page 595, and read about it. So change of base formula. The key idea here is that you can change any logarithm into a common logarithm. So instead of having log base 4 or log base 6, you can turn it into base 10. And just most scientific calculators have base 10. Can you go to the back? You want to ask a question about change of base? Say a question about that. So, for instance, log base c of a, you can rewrite it as log a over log c. And so, notice it no longer has a base. It has the invisible 10. Jake, do you have an ID today? There's the invisible 10 here, which is good because your calculator does invisible 10 calculations pretty quick. So this is very helpful for calculators that only have a log button and they don't have the other bases. Just move this.
evaluate log 3 using log.
Try this. Evaluate. Does anybody want to take a guess at what the answer is? 3 to what power is 8? Anybody want to guess? 1.8, maybe because 3 squared is 9. So something just under 2. Okay. So I'm going to change base. I'm going to do log 8 over log 3. Now I'm going to use a calculator. You guys have been asking me about this all along. On your calculator, you're going to hit this is the TI-36, you're going to hit the ln log button twice. Nope, that's not what I want you to do. First, I want you to hit the fraction button.
Hold on.
Then, you hit the ln log button twice.
Okay, I'm lost.
And then, you should be able to type in log 8 over log 3.
I'm not having to get some knowledge. In log, Let's try it.
Try your calculator, people. Get it out and try it.
Log.
I did it. Other sports have rankings.
It probably does somewhere. Let me come check it out. As it turns out, 3 to the 1.893 is approximately 4.
It seems like that big.
She's also wrestling. Yeah, she's like that wrestle people were having. Oh no, I had a.
Alright, any questions on how to get 1.893 equal? You got it? Use your fraction button, you got it? Daniela, you got it? You didn't do that? You did? And you didn't get it right? Okay. Successfully comprehension yet? No big deal, no big deal. Alright, let's check yesterday's assignment, and then you guys are going to practice this some more. You guys
Wait,
got
was this the? I got it right.
There you go.
I got it right.
So that's pretty much all I'm going to tell you about how to do that in your calculator. Alright, I'm going to check yesterday's assignment, but I know you want to write this down. Today's assignment is page 598, 29 to 35 odd. That's using change of base formula. And then you're going to do 2 to 28 even, and that's just like yesterday's work. So the only new thing I told you today is that change of base. The rest of it is still practicing from yesterday. So when you're ready, open your books to 597. So we can go through those answers. I told you to check your answers using the back of the book. So you should know right now what questions you have. Like I could not get to that answer. I don't know how the book said it. How about 1, 3, and 5? Or how about just 1 and 3? Does anybody have any questions about 1 and 3?
I guess they don't hang out as much.
I don't see that. Like I wouldn't believe I will go on. But I mean, after the whole thing. Wait, okay, so she needs to check these.
Yeah, maybe I saw cross-eyed. Literally gave me so much more. And I was walking out of the bathroom first thing I said, right there.
What was your difference?
Oh god, I was like itching and like souring at the mouth, but like I didn't.
Oh goodness gracious, you're so healing me. Louis, get off that phone. A little Luigi.
Luigi was funny. You should call my dad.
Luis. Oh, I love him. He's so cute. I miss him. How's he doing? I miss your dad.
He kind of took a banana. What? I'm trying to say something. He kind of took up a new lifestyle.
What?
He started with a girl.
Actually? What did she say? You're lying.
No, he's in the back of my house smoking weed all the
Oh no.
I'm joking. He's not Michael.
Hey.
You've been framed.
Oh, I thought it said.
You've been framed.
Oh, no, I got
Mhm. I'm not even gonna try to complete schizophrenia.
You know what's kind of interesting too?
What? I don't have.
And I'm gonna scroll lower so you guys can see some more. There's 11, 13, and 15.
I must survive. Hold on. It says 3 hours ago.
I'm not gonna give up.
You're a joke.
I wouldn't be proud of you. What penetrating
Oh wait, are we just doing the other one?
How? We do it. It was good, dude. Please.
I don't know. I can't. This is my boy.
Ew, bro.
Bro, sorry. He was like nice to me.
There's nothing to do about it. Find it out.
Okay.
I just like
I know the whole dance.
Oh, you know what I thought? You're gone.
Yeah.
The Kappa meeting.
No camera.
She was asking questions about the SAT.
Alright, here's
Was she so cute?
17, 15, 17, 19.
Do you want to see my homework from yesterday?
I didn't. Honestly, I didn't do it. 'Cause I had no idea what to do.
Wait, okay.
I
So
tried to do it and I almost cried.
here's
So.
yesterday. Did that in the back. And then from the other day, hold on, what page is that? Are you Oh, I found it. This is all of the
Okay, what is
the
it?
table,
Let's check it.
the graphs.
You know what tonight's
Tonight's homework is this.
the evens?
No,
Alright guys, let's look at 13. Everybody felt like they could not do this. Alright, direction says expand.
Oh my gosh.
When it says expand, and I'm gonna write this word, I want you to separate the coefficient from the variable. Okay, so I want you to see this as log 10 times x to the fifth. You know, like that 10, that x times the fifth, they're not concrete together. It's a multiplication sign. So this becomes addition. Multiplication becomes addition. So this is log 10 plus log x to the fifth. When you expand, you end up writing log more. Okay? So far, so good. Yeah. Next thing you do is you move exponents to the front of the word log. Log 10 plus 5 log x. Question so far. Now, your book shows this as a 1. That's because, well, we did a Bauer question last week that looked like this. And I said, think x to what power would give you an x? X, only 1, right? Whenever this and this match, it all equals 1. Well, there's an invisible 10 right here. If there's no base at all, it's an invisible 10. Alright, you need to write down this fraction.
Easiest for me.
That's for the one. That's
I really don't know.
the other day when I dropped you off.
You see them?
No, it's all you guys. I haven't seen anything else. Oh, you really no. I have a case for next year. Sure.
Do not. Dude, that would be so bad. I've already texted her and she hasn't texted me back. Every time she doesn't text back. Is it embarrassing?
A little. I'm gonna keep it real.
Alright, does anybody want to walk to the clinic?
Y'all are lazy.
Wait, look. Look at these past messages.
Yeah. I'll make my way.
Wait. Got this. Oh my god, are we working on 13, 17, 18? Okay. So it becomes a plus. Okay. Interesting. I did not do that. I brought the 5 exponents in the front for some reason.
Yes, but it doesn't go because the 5 doesn't belong to the 10. You can't put it to the front of the whole thing. You have to separate them into distances.
Oh, so you choose to move it.
Thanks for letting me get that spooky pooky.
Brady, whenever you on.
And then it turns